Today we're going to be working on area between curves using TI-84 because sometimes we'll encounter functions that's difficult to integrate, and to be able to answer a problem or calculus problem we need to use a calculator or graphing calculator to solve for the area, just like problem number 1 and number 2. So we have problem number 1. Let's compute for the area between the first function, the second function y, which is 1 minus cosine x, and the y-axis. So first, let's graph the function using the graphing calculator. So y sub 1, let's define y sub 1 in our calculator as e to the negative cosine, e to the negative x squared. So e to the negative x squared, and y sub 2 is 1 minus cosine x. So 1 minus cosine x. So that's our y sub 1 and y sub 2. Now if we graph this, we'll see that our graph is slightly small, so we're going to zoom it in so we can see our graph better. So using the zoom function, so push trace first and direct your graph to the point of intersection, zoom to, and we'll see the graph better. So by doing this, we'll be able to visualize what we're supposed to be solving, and in this case, so we have the blue graph, which is represented by push trace y sub 1. So this is y sub 1, the blue graph, and the red graph is y sub 2, which is 1 minus cosine x. So this is the graph of y sub 2. So since we are finding the area between the function and the y-axis, this is the region that we are approximating. So using the vertical method, or the top minus bottom method, we'll be able to find the integral from 0 up until this value of x. And to find the point of intersection, we'll use the calculator. Second function, trace for calc. Go to intersect, which is 5, and it will ask you to use the first curve and the second curve, which is the red curve, to approximate the point of intersection. And this is giving us 0.942. So now that we have all the things that we need, we can start writing out the integral function. So find the area. It's top minus bottom. And since we are using the limit from 0 along the x-axis, we'll use dx. So the area, by substitution, we'll have the integral from 0 to 9 or 0.942 of the top function, and the top function here is y sub 1 minus the bottom function, which is y sub 2 dx. So using our calculator, second quit, math 9, from 0 to 0.942, we'll subtract y1, top function is y sub 1, minus bottom function, which is y sub 2. Bars, y bars 2 dx. And it's giving us 0.5909, or we can round it up to 0.591. So this is the area between the curve using the calculator. Now let's go ahead and answer problem number 2. So we can start fresh. We have the function, two functions, and bounded by the y-axis. We need to find the area of the region R. So y sub 1, y equals, let's define y sub 1 as x cubed all over 1 plus x squared. So x cubed divided by 1 plus x squared, and y sub 2 is 4 minus 2x. 4 minus 2x. So the blue graph is the first graph, the red graph will be the second graph. So if we graph it, that will be our first function, and the second function is going downwards. So the first function is our blue graph, and this is our red graph. So let's zoom in, trace, and then zoom to, so we can see how the function look like. So this is our function bounded by the y-axis. So the red graph is y sub 2, and then the blue graph is y sub 1. So in this case, we're going to find the region bounded by the two functions and the y-axis. So we're also using the top minus bottom function method to find the area from 0 up until this value of x. So second function, trace, go to 5. So push enter 3 times, and it will give you the intersection at 1.4876. 488. So this is now our graph with the upper and the lower limit. So to write our integral function, which is from a through b of your top function minus bottom function, and it's dx because it's vertical, and translating it to our equation, we'll integrate it from 0 to 1.488 of top function, and the top function is y sub 2 minus the bottom function, which is y sub 1. So using our calculator, second quick, we'll be able to compute for the function math 9 from 0 up until 1.488 of y sub 2 minus y sub 1 dx. And it's giving us 3.2145. Let's round it up to the nearest thousandths. 215. 3.215 units squared. And this is how we use our TI-84 in computing for the area between curves.